Assalamualaikum. My name is Nurdania Afina. Today, I want to present my final year project titled The Physicochemical Properties of PC-PEG at Different Molar Ratio and Temperature. First of all, this is the structure of PC-PEG, where the structure of potassium carbonate and the structure of polyethylene glycol. For research background, first, recently, deep eutectic solvent or ionic liquid analogues have been considered as the newest green solvent, demonstrating the potential to replace harsh volatile organic solvents. Second, it has been found that temperature fluctuations influence the phase state of the DES and their viscosity and ability to dissolve. Third, varying the type of HBA and HBD and their ratio can simultaneously influence multiple physical and chemical properties of gas. For a problem statement, most of the reported deep eutectic solvents to date are highly viscous at room temperature, which is mainly ascribed to the extensive hydrogen bond network taking place between deep eutectic solvent components. My objective is first to determine the two best molar ratios of PC-PEG mixture based on their solubility. Second, to determine the effects of molar ratio and temperature on pH, hydrogen bonding, density, viscosity, and ionic conductivity of PC-PEG mixture. The significance of study is the study of effects of molar ratios and temperature on the solubility and physiochemical properties of the PC-PEG system may help to stabilize the mixture for specific applications in chemical reactions and material science. So, this is the finding I used for my literature review. For equipment and material, I use pH paper for pH reading, Perkin-Elmer FTIR spectrometer for FTIR analyzing, attention force tensiometer for measuring density, Brookfield rotational viscometer for measuring viscosity, eutect conductivity for measuring ionic conductivity. This is the results of solubility of PC-PEG after 24 hours. For FTIR of PC-PEG, we may observe this band around stated wave number. So this is the FTIR analysis and this is the hydrogen bonding observed. For pH, we may observe that pH of PEG initially natural and went to basic as temperature increased. For ratio 1:10, the pH initially mild basic then went to strong basic as temperature increased. For ratio 1:12, the pH initially basic then went to mild basic as temperature increased. For density, at molar ratio 1:10, the density is higher compared to 1:12, while density decreased as the temperature increased. For viscosity at molar ratio 1:10, the viscosity higher compared to 1:12, while viscosity decreased as the temperature increased. For ionic conductivity, at molar ratio 1:10, the ionic conductivity is higher compared to 1:12, while ionic conductivity increased as the temperature increased. So, the conclusion is the mixture demonstrated improved solubility at the 1:10 and 1:12 molar concentrations of PC2PEG. And because of the decreased resistance to molecule motion at higher thermal energy levels, viscosity decreased with increasing temperature across all molar ratios. Recommendation for future study. Lower viscosity gas, for instance, are typically preferred due to the enhanced mass transfer and ease of handling, which are crucial for efficient extraction process, and for pharmaceutical application, gas must have a suitable pH to avoid irritation and maintain skin health.